Okay, so good morning. So we're going to continue our discussion with Hadoop. So last meeting, you were able to install and configure it, just basic Apache Hadoop. So this is the raw Apache Hadoop that comes from the open source community. And as I mentioned last week during class, this is actually the hard way of doing things. In real life, you don't actually have to do that. In the class today, I'm going to show you how to use it, right? And not the hard way of doing things. But before we get into that, I would just like you to start. So stop sharing for a bit. I will share my desktop. Okay. So first, I'd like you to do this first. So let's start your learner lab first, because it takes a while to start the learner lab. Oops, let me just a second to remove the feedback. There we go. Okay, so start the AWS Learner Lab first. You can do that by clicking on this link here, right? You've already done this with your virtual machine exercise, your EC2 virtual machine exercise. So it's roughly the same set steps and procedures. You click on it and you pick the appropriate class. In my case, there are plenty classes and not all of them have access to the Learner Lab. It's only this class that has, so I'll select the appropriate class. Once you get to the appropriate class, you will be presented with the Vocarium Lab screen for the Associate Level Learner Lab. You need the Associate Level Learner Lab to run Hadoop-related activities in AWS. So let me repeat that. If your access is not Associate Level, if it's the entry level or the cloud level, then this actually won't work. So, but the links I gave you are all Associate level. Now, what we did the last time was you were able to start the lab and you were able to copy the AWS details here. So once the lab is started, you can copy the AWS details so that you can run it via the AWS command line. Now you can also start the lab here and you can run the AWS GUI here. Now, if you don't start the lab, it will tell you to start the lab. So let's start the lab first. Okay, so this takes a while to start. So that at least, so I start it now so that we can continue with our discussion first. Okay. So the last session, we left off with basic Hadoop. Okay, so we did this the last session. Right, so we installed an on-premise Hadoop installation. Again, none of your jobs today will actually require 4 gig. They normally just require 2 gig to run, but sometimes if you get an out-of-memory error, you may want to increase the memory, depending on the job you're running and the size of the data you're using. But the examples we were using in this class so far have been small, and that's why you don't need 2 gig RAM. However, there may be some exercises that require more. That's the reason why the minimum requirement specified here is 4 gig. We installed Hadoop version 3.3.2, which is the latest version, right? And we followed the instructions here. Okay. So this is the example we ran, and this is also the example that you ran as part of your activity or your lab assignments, right? So Hadoop jar, etc. So let's have a look at that. So let's start. So let me start running a virtual machine. So I haven't started my virtual machine yet, so let me power that up. Shouldn't take long. Okay, so it's booting up my virtual machine here. Then I can log into the virtual machine. Again, replace the username with your username. Okay, when the virtual machine boots up for the first time, the Java stuff or the Hadoop stuff is not running. So you go to the Hadoop directory and you start. So there's a shortcut for starting all the processes called start all. You can actually use that. That's to start. So if you forget to do this and you try to do the exercises, they actually won't work. Oh, I should have showed you that, but it's okay. So if you try to run the Hadoop commands without doing this first, it actually won't work. So this one starts all the Hadoop related components, right? So again, just as a recap, name nodes are basically at your storage layer that basically allows you to find where the blocks are stored. The data nodes are the actual nodes that store the blocks, right? And in the case of Hadoop, you do a distributed striping type setup, or depending on your replication factor, it stores the data many times across the cluster, thus providing shared nothing reliability. A secondary node is also part of your storage ecosystem. We did discuss it last week, but this is basically contrary to its name, it's not a backup to the name node. You can actually have more than one name node that can be the backup for the name node, but a secondary name node is actually it's an audit mechanism. It keeps a copy of the ledger files of the name nodes and stores it and manages the ledger. So it basically serves secondary functions to the name node. These are the key components of what we call the storage layer. Then you will have other components that are part of the processing layer. So job tracker. So in this case, it's resource manager and node manager, because we are using MapReduce version 2 or Yarn. So resource manager is basically the one that handles the assignments of jobs. It takes the job. So Yarn is yet another resource manager. That's what actually Yarn means. So research manager runs. So it's equivalent of name node, where you give the jobs to, and the node managers are the ones that run on the individual nodes of the machine. So in this case, it's all running. You can actually test by doing a Hadoop command. So we can do file system command, for example, Hadoop. Right? So Hadoop fsls will tell you, let's have a look. It has to be. This is one of those things that you might get confused at, because the AWS commands are similar but not the same, right? You can do AWS S3 LS, but you don't have to put a dash. In Hadoop, you have to put the dash in front of the command. So here I have an input directory, which I put the XML files that we used for testing the grep command, right? So those are there. So by running Hadoop command, so this means my Hadoop cluster is actually running properly. Okay, so for this class, we're going to be running another exercise, right, called Hadoop. We're going to be using a tool called Hadoop streaming, and we're going to be doing both in AWS and in our on-premise Hadoop, because the Hadoop test examples don't make sense running on AWS because they're only running in one node. But in order to run in multiple nodes, we can actually try and run it in AWS, which is what I will show you today, in addition to running it in Apache Hadoop. So we will be using a framework called Hadoop streaming. This is probably the most traditional way of running a Hadoop application, because we really have to build a MapReduce program, meaning you have to get your data, break it up by mapping it, right? Then you sort it, distribute it, and you reduce it back. And you have to write all the applications that do that. So in this case, you have to write at least a mapper and a reducer. You can write more components and pass it to the Hadoop streaming framework, but the mapper and reducer is the minimum, right? For today, I'm going to discuss to you the very, very popular word count example, which I use in this class because it's a simple enough application to describe MapReduce semantics. And we're going to be using the Bible text file, right? So that at least we can have a larger file than just a few XML files, right? Okay, so that's what we're going to be discussing now. So Hadoop streaming is basically a framework that allows you to write a MapReduce application in any programming language. In this case, we're going to be writing it in Python, but technically speaking, you can write it in any language you want, right? So in this particular case, you have to make sure that all the applications are in your system. I'll show you how to download it. And you should also be able to run it properly in your machine. And this is how you're going to run it, right? So let's go straight to the example. Okay, let's go first to our course management system page. So first things first, let's download the example. So I already wrote the example for you so that you don't have to retype it. You can copy it here. This is the Hadoop streaming example. You can copy the link here and you can download it to your So let's just create a directory, word count, and I will download. Oh, this might not work actually. Yeah. So I suggest you just download it to your desktop first, right? Then from your desktop, you can upload it. So in my case, it's in my downloads directory. I can copy it, MR streaming. And I transfer it to my Hadoop machine. Okay. So I downloaded it first. So please take note, I downloaded it first to my desktop. Then from my desktop, I transferred it to my VM. Now, it might be confusing at times because my desktop is also Linux and my VM is Linux. So sometimes they look the same, right? But they're actually different systems. So if I look at my Linux machine, at the home directory, it's there. See that here. So I'll move that to my word count directory. Just this directory. Okay, I will unzip it. And there are the files there. Now, some of you may want to, for example, you may want to just unpack the file in your host machine. So you can unpack it here also. So let me show you that. You can unpack it. Where's MR? Here. So even in Windows, it will kind of look like this, right? You can look at the README file. It can give you the instructions. It says, oh, copy bible.txt. So since this is an internet link and not a canvas link, you can download it from inside your VM. So wget is the command. And if you notice, I have my Bible cleaned up. This is the cleaned up Bible file. Right? You can also copy the version that's here. There is also a link to the Bible file here. I believe I placed one also. There's lots of stuff here. So this is also a link to that same file. Okay, so you have many ways of downloading the Bible, right? In this case, it's a text version of the Bible. Right? It's a bit long, so it won't display, but at least you have it already. Now, let's go back. So you have that file. Okay, then remove punctuation marks if necessary, but that's up to you, right? Now, this is a command that actually allows me to test if my mapper and reducer work, right? But before that, let's look at the source code muna of the mapper and reducer. So let's first look at the mapper. So for those of you who are familiar with Python, great. For those of you who are not familiar with Python, just bear with me as I explain this. So what happens in the mapper is you notice the Bible file. Let's look at the Bible file. It's just a bunch of text, right? There's text and words. And what we're going to do is we're going to count every word, right? Similar to your MapReduce word count example, we're creating a version of our own and not using the pre-built example. So in this case, these are the verses in the Bible and these are the text, right? And so there's a lot of words and counting them manually takes a lot of time and you have to write an application to count. Now, if you're going to use the MapReduce framework, the first thing you're supposed to do is you're supposed to map the data. So map means every word is separated, right? So since the unit of measure for this particular application is word, then that means we should break it into word. And the best way to break it into word is to use the split command in Python. So what does this application do? This application actually takes all the data from standard in, right? So the Hadoop streaming framework gets data from standard in, spits data from standard out. So the mapper, it expects, Hadoop streaming expects that the mapper take in the data and you tokenize it, meaning in this case, break it into words, and output the tokens as key value pairs. That's what it expects at standard out. So it's very simple. So that means You create an application that reads from standard in. So this was the four line in standard in. This one is part of the sys library. So what happens here is that your file, in this case bible.txt, is read one line at a time, right? The first command here, line equals line.strip, means it just removes the new line character at the end, right? Then it breaks, line.split breaks the line into words. So this is the tokenizer step. Now, since we're counting words, this is okay. So the keys are now words. And for key in keys, right? So you will do this, right? So for every key in key, the value is 1, right? And it just prints key value pairs, right? So the key, then separated by tab. So tab separated key value pairs. Now, if we run this application by itself, so for example, cat is a command that just spits all the output of the text file into the screen, right? So I can pass that into my mapper application. If I look at that, pass it into my mapper application, I can see that what it simply does is all the words, that's just so head is another command that only really picks the first line, right? And I pass it into mapper. So that means it simply got the line, right? The first line in bible.txt and broke it up into words. So notice, kahit na umulit yung word like the appears here 3 times in this sentence. And the reason being is the job of the mapper is not to consolidate. Trabaho ni reducer yan. The job of the mapper is simply to tokenize. And every token has just a count of 1. So that's the only thing the mapper does, right? Then, of course, the next stage of a map reduce is to actually sort, right? It sorts the output and it distributes it across the cluster. But syempre, I'm only running it on one node just for testing. So if I do that here, let's do our one line and you do sort. If you notice, all the thus will come together, right? And this basically allows you in the real Hadoop framework to do distributed. Then when we look at the reducer code again gets the key value pair, right? So in this case, it reads the key value pair from standard in with each line being a key value pair. Again, click muna to remove the new line and splits the key and the value. Key here, the value here, using the split command, but instead of just the default split command that splits it by white space, this one splits it by tab, right? Then I create the value portion is supposed to be an integer, so I force cast it to an integer, right? Then if it's not the last key, I simply read the key, right, and add it to the total value. So lahat ng the mako-consolidate. So if I run that and pass it to reducer, then the becomes 3, right? If I give it more lines, let's say I give it first 5 lines, then at least more words will come out. If I want the whole Bible to be processed, right, it takes a while, right, because it's a fairly big file. Once it's done, the output comes out. And if you notice, it's sorted by the string, not really by the value. So this is how MapReduce works. And this is how you test your Hadoop string. It has to work here first. This line has to work first before you are able to use this, right? So this one is not running in Hadoop yet. It is simply just to test that your mapper and your reducer scripts are working properly. So once you're done, you can actually run it in. But first, I have to upload bible.txt into the word count folder. So let me create a word count folder, Hadoop. Hadoop. Sorry. Let's just do Hadoop. Okay. Tapos fs mkdir word count. So I create a folder called word count. Okay. I look at my directory to check if word count folder is there. Yeah. Let's see what is inside word count folder. Nothing yet. All right. So let's copy Bible. So Bible is in my machine. I will put it, sorry, let's use put into word count. Okay. So I put the Bible.txt file that's in the current directory, and I load it into the word count folder. I look at the contents of the word count folder. Yeah, Bible.txt is there. Actually, there's also this command. You can see what's inside Bible. Right. Just to see if it's really there. Okay. Okay. So now this step is done. Download the contents and I make sure it's uploaded into the MapReduce. Then I can run this, right? So this one, let me explain what the command does first. This one again, Hadoop. So it runs it on your Hadoop framework. Jar, like the examples, right? Examples means runs this particular program that's packaged as a jar. In this case, this is the program. It's called Hadoop Streaming, and I pass the files, the MapReducer, and I say the input is Bible.txt. It can be the whole folder, by the way. It doesn't have to be the Bible.txt file itself, and the output is the output. Of course, I will use a different output because this output is already taken. And as we know, Hadoop will fail if the output directly exists. Let's do jar, and let's run Hadoop. So the streaming jar is probably in lib Hadoop. No. User lib. Wait, let's find it first. Should be maybe in share Hadoop. Now let's look for it first. So let's look for the Hadoop. Find Hadoop streaming.jar in my home directory where the Hadoop is. There. So find that file. Oh, it's not there. Hadoop streaming.jar. Yeah. Let's look for all the jars. There you go. I forgot to put the quotes yet. So it's in share Hadoop common lib. Okay, so this one is jar. Share Hadoop common lib. Hadoop. Walang streaming. Let's see. This version of Hadoop. Hadoop stream. Yes, Hadoop stream. But the Hadoop streaming jar is missing. Yeah. Let's see. Yeah, so let's pause this for a while because the Hadoop streaming jar is missing. It should be here. This version doesn't have it. Yeah. There is missing jars. Yeah. So let's skip this for now. While there's some streamings here. Hadoop streaming. There, so I found it. So here's the Hadoop streaming jar. Let's just copy its location. So the reason why I couldn't find it is because there was a version number. Okay, so now let's go back. Okay, Hadoop streaming jar. Put it to the version of Hadoop streaming jar, right? So it's there. So let's pass its parameters. So files, mapper.py, reducer.py, which are in my current directory. Then I name the mapper, mapper.py, reducer.py, right? So far, so good. Input, word count. It can be the whole folder. Output, output 3, right? Because I think 1 and 2 are taken. All right, so again, breaking it down, this is the Hadoop command jar. I had to look for the streaming jar, so it's here. I just missed it because it has a version number, right? Files. If you're using 3.2, this will be 332 instead of 331, because I think 332 came out while we were doing the class. Then the files is mapper and reducer. The reason why I put files is because it's going to pull the file from my local directory. That means I didn't, if you notice, I didn't upload mapper and reducer to the HDFS. Only Bible was updated to HDFS into the word count folder, right? So I upload these files and I say, okay, the mapper file is the mapper.py and the reducer is reducer.py. Then I specify the input folder, word count, and the output folder, output 3. Okay, and I run it. Right, so that's effectively what this is, just translating it to the Apache Hadoop version that we are running right now. Okay, it will take a while because this actually powers up a Hadoop cluster and all of that, but that is really what this command does. So I'm going to run a mapper reducer. Now, if I don't specify commands, for example, you can specify a custom sorter. I didn't specify a custom sorter, so it will use the pre-built sorter, which is similar in behavior to the sort commands. Questions so far before we, while waiting for this to finish? Okay, so this is the traditional way. Now, different programs, like you might be instructed to do different things, right? Instead of counting words, you may be used to count DNA base pairs, right? So when you do that, you have to modify the mapper and reducer files depending on what you're trying to do, right? So again, the mapper file is really just to create key value pairs, and the reducer file is to count the key value pairs and to sort them out. So this one is successful. There are no stack traces. So if you notice, it successfully ran. It will give you parameters of the run. So let's take a look. So output is an output 3. Let's have a look. Okay. Let's check if output 3 exists. So let's look at the output 3 folder. It's there, right? There's an output 3 file called part 1, 2, 3, 4, 5. I can just display the output of output 3, and it will show me a summary of all the words and the word count, right? Just as a word of warning, the sorts may not be the same. If you notice, capitalization, I think, is higher than this one. Well, this one is, in this case, but in the regular Unix sort, you notice that the capitalized and uncapitalized letters are together. So just take note that different systems have different sorts. Then that's the reason why sometimes you have to create a custom sort of your own. But if, for example, I ask you the question, how do you determine the most popular word in the Bible, right? So that is your lab exercise that you're going to submit. You're going to do something to obtain that information, right? So you're going to modify the application to process the books, right? You may not be able to use this file per se because this doesn't have the books, right? Okay, so that's your lab exercise, the upcoming lab exercise. Questions? So this is running Hadoop streaming on this machine. Now, if you notice, it only ran on one machine because it is in pseudo distributed mode. Next, I'm going to show you how to run exactly the same program, but in Hadoop, in AWS, right? So here, my lab is started. Oh, sorry, AWS details. Let's check if the lab started properly. So in this case, you will see, yep, it started already. You can click on this. You should have access to AWS Hadoop tools, right? This Hadoop tool that we're going to be using is called EMR, or Elastic Map Reduce, right? So that is what I'm going to show how to use. But before anything else, again, you have to upload stuff into the system. So let's do S3 first. This is the file system, the distributed file system service of AWS, right? And I'm going to upload my test here first. Okay. So first things first, let us create a new bucket. So let me call it test CS173- word count. So I will create a bucket that's just my own. So all the other permissions are disabled because I don't need to share this particular bucket. Right? So I created that bucket. And that bucket, I'm going to upload the files that I need. So in this case, oh, let me unpack that first. So here, I will unpack it. I will also download the Bible here. Let's copy that. Okay, so that they're in my folder. I go back here and I can upload them now. So let me look for them. Downloads Bible, the mapper, and the reducer. Okay, so upload them and upload. So the reason I upload them is anything you use in EMR must be in AWS. So I'll upload them in S3 first, and I'll show you how to create a job in EMR. Okay, so I uploaded the data. I uploaded my application, which is a mapper and reducer. And if I check, they're inside. Yep. So then test CS173 word count is the name of my bucket. And please remember the name of your bucket. Then let's go back to services and let's go to a service called EMR. Again, as I mentioned, EMR is the Hadoop distribution or the Hadoop framework of AWS. It's short for Elastic MapReduce. It allows you to create temporary big data jobs, meaning you can power up a big data job and it will create a cluster for you, whether it's 2 nodes, 10 nodes, 100 nodes, runs the job, and once the job is over, it switches off the cluster for you. So this is perfect for our class because then we don't have to install Hadoop. We don't have to install it in each node. EMR does all that for you. We simply have to set it up. And this exercise we're doing right now is how to set it up. So create a cluster. I will just call this test CS173 word count streaming sample. Okay. So I enable logging because you need to know what's going to happen. The first thing you're going to do is select step execution. If you select cluster, it's going to create the cluster and to leave the cluster running. Like your Apache Hadoop, you can log into it and you can run jobs. But that means you have to switch it off and set it up yourself and all the things that I did a while ago. Specifying the streaming jar and all of that you have to do. By doing step execution, you can simplify that process. There is a streaming program, right? Type would be streaming program, and we click configure. And I specify the mapper. Notice all the directories here are S3, so I specify it. So the mapper is mapper. Then I point it to the reducer. Again, since this is a MapReduce application, everything comes in standard in, standard out, right? Then I specify the input location. In this case, oops. You specify that file, not the whole folder because there are other stuff in the folder. I don't specify an output because what I did in my reducer, the output went to standard out. So I just have to look at the output in standard out. So I don't have to specify an output folder. This is all optional arguments in our application a while ago. We didn't specify any. And action on failure, terminate cluster. Right? If you don't do terminate cluster, and this is, I highly encourage you to terminate cluster so that when it fails, it simply turns off the cluster so that you can look at it again later and see what failed. Right? You can look at the log files. That's why we switch logging on. If it succeeded, it already wrote the output in standard out, which will already be in your logs. So terminate cluster is important because if you don't, what will happen is it will try to power up the cluster. It will try to run. The run failed, but it keeps the cluster up and running, right? Now, this is good for troubleshooting because if the cluster is up and running, you can actually log into it, right? You can log into it and you can do your troubleshooting there, right? But if once you're done, then you have to switch it off manually yourself. But since we're doing this more batch style approach, it's better to terminate cluster. So please don't forget to select this. Okay, so now it is configured, right? Streaming program. This will ask you what version. So I normally just use the default versions. So there are many EMR releases. There are newer EMR releases. The one we ran a while ago was the latest 3.3.1 or 3.3.2. So you can select newer versions of EMR. They're less stable than older versions. Now, even if you use the older version, it's okay. But let's see. Let's try the newer version here. Okay. Then you specify the size. Okay. So now we don't need very big. But the nice thing about using these M5 cluster types is it normally provisions faster because they are generally available. So for this class, let's keep it at that na lang first para it will provision fast. But this is really overkill na. And I specify 3, so 1 master and 2 nodes. Now this one will not run faster than the 1 node because the data is so small. But if you're running a really big, job, then this one will matter. You can specify it here. Okay. This is a new feature actually. This wasn't here before. What this probably does is that if the cluster is running slowly, it can actually add nodes to it. But again, the mechanics may be something we have to read up. And this one is on auto terminate. So if nothing is happening in the cluster for 1 hour, it terminates. Again, that's another new feature as well, which is good because you don't want your load to be consumed just because you forgot to turn off the cluster. All right. Then the security is just the default, right? And we click create cluster. And we wait. This thing takes about 15 minutes, so we may not have the time to wait for it, right? But you will see it's running here. Okay. If you refresh it by clicking on this button, you will see the updating status, right? So the first step will really be to provision. Now, this is the step that takes the longest because this is the AWS portion. So they're trying to provision it, right? You will see the logs. They will be posted here. This is an S3 bucket also, okay? Now, just some housekeeping. So here we have to wait. There's really no choice. You just have to watch the status. It will return to the status whether it succeeded or failed. So I'll show you some examples of my previous runs. So this is a previous run that I had with an error. So if you notice, it was terminated with error. I can look at it. It says terminated with error, shut down, a step failed. So that means it tried to run the job. This was also the Hadoop streaming. So I ran the same Hadoop streaming application. I ran it here and it failed, right? But in this case, the cluster terminated because I told it to terminate. Now I can look at the steps to see where it failed, right? So there are 2 ways to access the log. You can access the log here, which is medyo raw and you have to find it. Or you can just go here straight to steps because this is a stepwise execution. You can go to steps and you can see where it failed, right? So it said here, exclamation point, right? Failed here, so failed. This one succeeded, the setup of Hadoop. Failed. Output directory already exists. Again, one of the most common errors in Hadoop is trying to run here. This is trying to run the streaming exercise, but I specified the output folder, and it failed because the output directory already exists. So if I look at system log, you can see the actual log files, same, and it gave me the same error, right? Output directory already exists. Now I'll show you a successful one. This successful run. So notice it says terminated steps completed. We go to steps. There are no errors here, so completed, right? And you can view the logs. Standard out will show you the output. In this case, there's no output. Here's standard error. Right? So no errors, right? And it's saved it in output 1. This one succeeded, right? The other failed. So those are examples. Now let's look at the screen itself. If you notice the screen, this means it's not running anymore, right? This one is still running. So you will see it's still attempting to provision the cluster. isn't done yet. In this case, the hardware has been provisioned already. It's already provisioning the software. So it's installing Hadoop for you and all of that. Now let's look at the S3 bucket of the previous runs. See the differences in the applications. So test CS 73, create streaming folder here. So if you notice, let's look at the reduce application. Oops. Oh, sorry. I accidentally closed it. Let's go back. It shouldn't vanish because again, all of this is batch. Once you give the instructions, it should continue to run it, even if you get disconnected. Let's look at let us let's download this. There. See, so again, it's the same reducer of application that was specified. Okay. Let's go back to EMR. Let's see where are we. So since I picked a popular VM size, it should be readily available. Because if you notice, the hardware was provided fairly quickly. Right now, this is the software portion. It's taking a while to install. Okay, so in this case, we just have to wait. Okay. Questions so far? So again, if you notice, running it in your own Hadoop, it required a lot more steps. You had to configure your own VM, you had to install the software, you had to install the application, and once the application was running, you have to set up specify mapper, specify reducer, run the appropriate, look for the streaming jar, and all of that. By running it on a cloud-based environment like AWS, those things have been specified for you, right? So you don't even have to install the software. You don't have to install the hardware for sure. It's provisioned by AWS, but even the Hadoop software and the operating system is already done for you, right? So that's why this is better, especially when you're running a provision size. So in this case, it's already running. So this should be fast. If there's an error, you should see the error right away. If it succeeds, you should see succeed right away. So here, they're both already run. Right, so it's probably setting up the application software and it will run the application software. Okay. Of course, if you want to run this in AWS CLI, you can actually export the CLI command here. Right, and this one you can run it on your Linux VM to specify it. But in this class, I don't have a preference. You can run it via CLI or you can run it via the GUI. That is okay, because what we're testing is actually your ability to write the streaming program as opposed to being familiar with the system administration mechanics of an AWS cluster. Okay, so it's now running the steps. That should be fast because the file is fairly small. In this case, I am running it on a 3-node cluster. So one serves as the master node and 2 will serve as the compute node. So if you notice, I don't have to have three nodes myself. And unlike the MPI example a while ago, this particular mechanism, EMR, bootstrapped it for you, right? So it created and powered up the cluster for you, set up the environment for you, installed the operating system for you, and ran the application for you, right? So this one will fail, right? So if you notice, it's exactly the same, still pending. So let's see. Cluster, so it's not yet done. Let's wait a bit for the output to complete. So now it's terminating the cluster and it failed, right? So let's look at that. The error is unknown error. We have to look at the log files. They're not there yet. Let's wait a bit for the log files. The output argument is required. See, so again, Let's look at it. So this is the same. Here, this one I specified an output, but it already exists. Where's my configuration? So just a sec. Let's look for the. This one is I specified an output. The output folder existed already. So that means we're supposed to run it with an output folder. So hindi pala pwede wala. So let's do that again. Yung one other way to do this is to press the clone button. You can clone it with the existing steps, and it copies the configuration of your previous run. Right, so let's go back to one. Let's check the steps. So here, this is where the mistake is. So I will specify a and output one. Okay. And I can run that. Select step type streaming. Right. Then, so this is just the advanced configuration. Most of the steps we don't have to specify anymore. Right. This one is I can keep that because that powered up quickly. Auto terminate. No need for scaling. Let's call this example 2. And I can leave this. Although I can specify a key pair. If I want to log into it, I'll specify the key pair that I have. So let's do that. But I'm not going to log into it, so it doesn't matter. Okay, so then another, I think the last one took 7 minutes. So this one should probably take the same amount of time. But in this case, this one will work. All right. Then I will show you successful output. So the previous run had successful output. So that's in CSEI 173. Streaming output. Right. So in this case, it split the output into 3 files. And this normally happens because you have 3 nodes. So normally it's one output file for node. You take them together and you process them in your local machine to combine. And since they're smaller files, hypothetically, they should be processable faster. So here, you notice here, see. So it's the first part, then the other parts will be inside. So that is what the output is like. Okay. Questions? Right, so that's it for Hadoop streaming. Let's take a look at the EMR execution. Again, this should be quick. That's provision. Okay, so that is basically Hadoop streaming running on both Apache Hadoop. So I ran it both as a command line, just this one. I ran it on Apache Hadoop. But again, please take note of where these files are. Okay, so they may be in a different folder. That's why you have to look for them. Right, yeah, be careful, but where the file should be. And this is running it on EMR. This is just a short description of EMR. It's a pay-as-you-go model, but you as part of AWS Academy, which our academic institution has, you don't have to pay a cent for this. So it provisions the cluster yourself, and that is what we were running on. Again, you have to have an AWS Academy account, which you all have. If you don't want to use an AWS Academy account, by the way, you can use your own AWS account, but you have to provide credit card information and the like, right? And you have to pay for whatever resources are using. Normally for this class, if there are no, if you don't forget to turn off clusters and things like that, your spend should be at around $25 level for the whole SEM. Okay, so that's what we normally spend for this class. However, for AWS Academy, you all have $100 credit. Okay, just be careful to ensure. Just be sure to turn off clusters after you use them. AWS CLI, we already installed this, so this should already work. So here is just a quick introduction of the key components as I showed you a while ago. So EC2, you already done in a previous lab exercise. This is basically to power up a VM. It's similar to installing the VM in virtual box, which you did as part of an initial exercise and when we were setting up the system. You also saw me use a simple storage service or the S3 service, which basically loads files, allows us to load files into the AWS ecosystem. Now, unlike running it on your own machine, you have to make sure that all the files, including the program files, like in this case, we're using Hadoop streaming, the mappers and reducers have to be there, right? They have to be loaded already. So you have to upload them to S3 first. Then we used the Hadoop framework of AWS called Elastic MapReduce, which has this neat feature called stepwise execution. Stepwise execution allows you to set up majority of the activities in the class, allows you to set them up as steps and to run them as steps so that they run. You wait, like right now, we're waiting for that step to finish. Once that's complete, then we can look at the output. So it's just really, really nice. Or you can configure it in cluster mode, which you can boot up the cluster, log in the cluster like the traditional way of handling cluster compute. But in real life, you're more focused on the data, right? So stepwise execution is really useful, especially if you don't want to deal with the semantics of setting up a Hadoop ecosystem. And of course, CloudWatch basically gives you the logs and the metrics, right? We don't access it directly, but you see them as it stores the logs and performance execution things. So these are the 4 things we're going to be using a lot of. In Elastic MapReduce, there are a lot of features. There's also a notebook feature that we will be using when we do Spark execution and the like. So there are quite a bit that we will learn about EMR and S3 as we move along the semester, right? So that is what we're going to learn in this class. However, AWS has a lot more. And of course, Azure and Google have a lot more features, but I'm only teaching you the basic features to do majority of your high performance computing needs. But in order to either make things simpler or to use specific, specially built databases, there are a lot more features that you can use. For example, Glue is a very nice framework for collecting data from different systems, especially when you want to operationalize analytics, right? You also have things like special databases like RDS and Aurora or DynamoDB, which are special types of databases that structure data in a particular way. You will also have Kinesis, which is an analytics platform, or Redshift, which is a data warehouse platform. It can store data and you can use it to analyze data as well. So there are many, many tools that you can use. But for us, we're doing the minimum viable product, right? So it's S3 and EMR. And we're manually loading the data into S3, or we're using data that is already in S3. So some of the exercises I will tell you to do already use data that has already been uploaded to S3. Okay. Now, the other platforms, right? So, of course, AWS is not the only game in town, right? You have Microsoft and Google as well. Microsoft with their Azure platform, they also have a Hadoop framework called HT Insight, right? Which is pretty useful also. And Google has a similar framework as well. Of course, as the inventors of the MapReduce framework, they have their own pipelines as well. Now, which one to use? It's really up to you. I have this philosophy: use the best tool for the best job, and it's also a function of your comfort level with respect to tools. Now, do we use AWS simply because we already have a partnership with them, and they have a framework for creating labs that allow our students to try out in a risk-free environment, right? You don't have to worry about overspending because there are spend limits and there are mechanisms that prevent you from overspending, right? So these are the things that you can look out for as well. But if you really want to use Azure, Microsoft Azure and Google Cloud, go ahead. For this class, we're actually also going to be using Google Colab, especially when we are discussing the machine learning. So running machine learning examples inside scikit-learn, and we will also do them in Spark, in Spark, right? Spark ML or Spark Machine Learning. Okay, so again, we're not limited to AWS, but for this class, we'll be using the hard way, which is Apache Hadoop. So we'll run that for all the tools. And we're also going to do them using the easy way, which is with AWS. Okay. And this is what the flow would normally look like. So EMR doesn't actually run anything itself. It just sets up an environment. It sets up a bunch of EC2 instances, like the 3 nodes we're doing. It gets the data from S3, runs it on the nodes, and puts the data back out to S3 and reports the metrics to CloudWatch. So that's essentially what that example I showed a while ago, which is running right now, does. Right. Now, today, we discuss Spark streaming. But EMR has a lot more. Sorry, Hadoop streaming. It also has Spark, Hive, and Sharp, for example. Although we'll not discuss Sharp, we're going to be discussing Spark QL in addition to Spark. So there are many tools that we're going to discuss. There's also another tool called Pig that we will also be discussing, although I think we're out of time for that. Right? So again, you need an AWS Academy account, right? And here are some other steps on how to do things. So we did Hadoop streaming now. We will do Pig next, then we will do Hive, then we will do Spark. Okay, then we will do Spark on notebooks, right? So here are the overviews, but these things we will discuss in the next session. So these are the activities that we're doing right now. We've stopped here at EMR. Then next, install and configure Pig. Okay. So let's look at our execution. Let's see where we are. You should have succeeded already, right? So notice steps completed. Now, if you look at the main page, it is steps completed, terminate class. It's still running, but at least it's terminating already. So what thing I really advise you to do is once in a while, check the stream to make sure that nothing is running. Now let's look at the output directory to see if we have our output already. Okay, here. Output 1. There you go. Okay, you can download this. So you can just click 3 of that. Download. Download in one go. Strange. So you have to download each and every one. Right. Of course, I downloaded it twice now. Okay. And you will have the words sorted. Now, this one is bad. If you notice, the punctuation marks are there. So that's the lab exercise. Basically, you are required to clean that up. So the next lab exercise, streaming, I believe. Where's that? Here, sorry. Streaming, right? To remove that. Now let's cover Pig quickly, since we are here already. So let's go back to our VM. This is our VM. Let's clean stuff up. Okay. I did not download Pig, so let me download Apache Pig here. Let's see what the latest version is. So let's download, okay, 0.7. Now, Pig is no longer very popular because there are better tools like Hive, for example, and Spark that have gained popularity, but it's still one of the more easy to use Hadoop tools. While that's downloading, this one, so I'm done with my AWS, right? Everything's closed, so let me end my lab. Let's look at the Pig example. AWS as well. There's a streaming step also for Pig, but for now, I'll show you an example that is not there. So let's download this. Okay. So while it's downloading, I'll explain to you what that application looks like. So the file is done EMR Pig example, right? So in this case, it gives the instructions on how to install Pig as well. Make sure Hadoop is there first. Then you can download the test file that we're going to use, and you can run the command using Pig. So this is the examples of running Pig. Okay, so let's do the download. Right, it's done. I can unpack it. Oh, it's there na pala. I downloaded it twice today. So I unpack it. So 0.17. So if you notice in the years of teaching this class, Pig hasn't moved. It's still 0.17, but Hadoop has moved quickly. That shows that Hadoop is actually much more popular than Pig as open source software. Okay. Save space and remove that. So I have Pig, all right. I set the environment. Now, the environment, I do this every time I start Hadoop, but now I'm using Bitcoin 3.1. Right. Let's do that again. That didn't come out right. Equals Hadoop 3.1. There you go. Now this one creates something called an environment variable. So you can see environment variables by doing this. Put the $sign in front and it sees that. If I have a Java environment variable, no, Java home. But anyway, Hadoop home. There you go. So I need to do that. If you want this to be permanent, right, so that every time you boot up your VM, this gets done, you can edit a file called bash rc. You can put it here. Right. So that means every time I start up my VM or I log in my shell, it actually puts it there as well. Okay. Just to show you, I added this here. But the next time I boot up my VM, nandyan na siya. Okay. Then I go to Pig. First, let me download this example. So I need to download that. So let's look at it first, see if my AWS is okay. Now, oh gosh, I shut down my AWS already. So my Vocarium lab. I should have left it running. Let's run it again. So this one is to download that sample file. Right, so there's a sample file here, and I should put it in my HDFS directory. Right, so let's see what I have. Okay. Oops. I can put it in let me name it. This is a reviews, right? So I can put AWS, Amazon reviews. Okay. Let me copy this. So my AWS credentials. See if it works now. Should. So I can get it. So I download that sample. So this is actually AWS reviews, if you notice. So it's a tab separated file, the marketplace, so in this case, US, customer ID, what they bought, and the rating they gave. I can upload it. So this is an example, but this is a very small example. I think this only has a few rows, 50 rows lang, right? So I will now upload it to my Hadoop environment, put sample and Amazon. Okay. So it's now in HDFS. In order to process files in Hadoop, the data must be in HDFS, right? Again, it must be distributed for it to benefit. Let's look at Amazon reviews. See if it's there. Should be there. Okay. Next is I run a command by running the command pig. Right, so pig is installed here, pig vim pig. So let us set Java home. And I did not set it. So let's look at the Hadoop environment. Java. See the environment. Let's where did I set that now? Let's Hadoop and okay, let's copy the Java home. There you go. Let's also put it here so that the next time I start my machine, and of course, let's run it now. Just check. Okay, let's go back and let's run pig. Sorry. Okay, let's see if this works. This is how you load the file. Again, you can put this in a pig file and you can run it, or you can run it like an interactive command line. Okay, so far, oops. Naputol siya. This may not work. I think mag-error yan. So let me edit this file na now properly. There. So that we can copy it. Because it has to be in one line lang. Kasi. There you go. So it's just one line. A equals. So what this means, what this command means, is that I am loading sample.psv, which in this case should not be sample.psv. It should actually be Amazon or sample.psv, right? Then I specify a format. So the first is a marketplace, etc. So it's like a database I set up. Right. So in this case, it loads it. Of course, it takes a while because it's again, it's a map reducing and powers up the cluster. It loads it, etc. Okay. Of course, it sets up Hadoop. So Hadoop is actually not fast if your jobs involve files that are this small. If they're larger files, then they actually make sense, especially when you're using database of files that run across multiple nodes. So Hadoop basically just makes it easier to run multiple files across the nodes, but it's not very good at running, is a single file lang na kaya ng isang machine. Okay. So it ran the job right here. And it spit out the output. Look, this is the output of the file. Now, next is I can actually do a lot more database things. So I can filter. I can create a filter. I want to return only toys. And notice it doesn't run it until you do the dump. So you can type all the commands and it doesn't run it until you do the dump. So which is actually quite nice because you can set up the entire environment and it only actually does the job when you run the dump. And what that does also, if you can optimize the query to make sure it maximizes resources. Okay, this ran fairly quickly. Right, this one, if you notice, only toys came out. Right, toys, right? So it's a filter. So let me try these other things. So toys with 5-star rating. So this one is, this is everything with 5-star rating. I can do toys with 5-star rating by just filtering P. All right. And I can group by star rating. Let's run this toys with star rating first. This one is just the toys and on the toys with 5-star rating. So I modify this example. Instead of running all with 5-star rating, I use B. I put B in here. That means I'll return only toys with 5-star rating. And you can do like any, database like queries, you can actually do group by and you can sort it, right? So this one, let's run next. Let's do a group by and let's sort it. Right, but let's just do it in one go. So here, notice it's just the 5-star rating. So 5-star, 5-star, and they're all toys. Toys. Okay. Let's run this and let's also sort it. And let's dump. Okay. So I want to see all, not just the toys, all. Or let's do to. I want to see all that are sorted, grouped by the rating, and I want them sorted by rating. Okay. So that's that. So again, this is your first application that is kind of database-like, right? As opposed to streaming. If you notice, streaming has no database semantics. You don't filter, you don't buy. You actually tokenize and you process each. But this one, at least it allows you to treat it like a database. So people like tools like Hive and Pig. Hive we'll discuss next meeting because it allows you to stream, which makes it a lot easier to process. Okay. Questions so far while we wait for this to run? Right. So again, your 2 assignments, your 2 lab exercises for the following week will compose running Pig and running Hadoop stream. Although mas useful is Hadoop streaming. That is right. So Pig, if you notice, SQL-like yung syntax, diba? This filter is like a where, right? Where clause. Right? Filter is the where clause. Group is like group by, right? Then order is order by, right? So it allows you to do that. But next meeting, we're going to be discussing a library called Hive that's actually SQL syntax. It's actually select, asterisk, etc., which is a lot better, right? And a lot cleaner, and it supports a lot more data structures as well. Okay, here it's done. So 5-star rating, we have 33 reviews with 5-star rating, 4 reviews with 4-star, and so on and so forth. Okay, so that is it for this particular session. Just as a reminder, before class next meeting, can you please download Hive already? Depending on the speed of your internet connection, you will be needing Hive, this one, for your next class. Okay, so please download the latest version of Hive 2 in your machine before class time. Okay, so that's it for today. So thank you very much. Are there any questions? Okay. Sige. And don't forget the 2 assignments. All right.